Integration by parts. In this section, we are finding one more method of integral. In last classes, already we discussed two methods. What are they? Integration by substitution method. Second one, integration by using the partial fraction. So now we are finding one more method which is helpful for the integration, that is the integration of product of two functions. Integration of product of two functions. So integration of f of x into g of x dx. The functions are in the form of product f of x and g of x. Here f and g are in the same variable x. So what is the formula for this? See now proof of the formula. So the derivation of the formula. We know that the derivative of product of the two functions, that is d by dx of u of x into v of x. Here u and v are same in the same variable x. The product of two functions is equal to what? U of x into d by dx of v of x plus d by dx of u of x into v of x. The product of two functions is equal to first one into derivative of second function plus first one derivative into second one. So one function we are deriving, second function we take as constant. So this function, this formula we know. Now you apply the integral on both sides. Now you apply the integral on both sides. By the basic law, conditions of the integrations, like by the properties of integrations. So integration of derivative of any function is equal to getting same function. That means integration of derivative of some h of x dx is equal to what? H of x only we are getting. H of x only we are getting. So like that. So you apply integral on both sides. Left side integration derivation is cancelling u of x into v of x. That is equals to integration of u of x into d by dx of v of x into dx. Now for this function also we apply integral. So integration of d by dx of u of x into v of x over dx. Right? I apply integral on each term. So left side integration derivation is cancelled by the properties of integration. Right? Now some important assumptions is there. What I am assuming is let u of x is equals to f of x. Then d by dx of u of x is equals to what? D by dx of f of x. Okay. Now one more, d by dx of v of x is equals to g of x. Right. Now we apply integral on both sides. So left side integration derivation is cancelled. So what we are getting? V of x is equals to integration of g of x dx. Understood? So what we are assuming here? U of x is equals to f of x. Derivative of v of x is equal to g of x. So first function you apply derivative, for second function you apply integration. Now you substitute here. These values substitute in this equation. So u of x is equal to what? F of x. V of x is equal to what? Integration of g of x dx equals to integration of u of x is equal to what? F of x. Derivative of v of x is equal to what? G of x dx plus integration integration of d by dx of u of x is equal to d by dx of f of x, because u is equal to f as well. Next into v of x is equal to what? Integration of g of x dx. Whole dx. This whole dx I have as it is. Now this function is taken to left side. This term is taken to left side. So f of x into integration of g of x dx. This is taken left side minus integration of d by dx of f of x into integration of g of x dx whole dx is equal to what? Integration of f of x into g of x dx. So this one is taken left side, this becomes minus. So that is equal to right side what we got? Integration of f of x into g of x dx. So finally integration of f of x into g of x dx is equal to what? This is equal to f of x into integration of g of x dx minus integration of d by dx of f of x into integration of g of x dx whole dx. This is the formula for finding the integration of product of two functions. Now, see now the integration of product of the two functions. First function into second function. First function into second function is equal to what? First function into integration of second function minus integration of derivative of first function into integration of second function. So just you remember like this. Integration of the product of first function into second function equals to first function into integration of second function minus integration of the product of derivative of first function integration of second function. Derivative of first function integration of second function. Like this you remember. So first function, second function is same. So how we are selecting first function and second function? You see, which is easily we can find the derivative. Which function derivative easily we can find. That function you take as first function. That is f of x. Which function derivative? Which function integration? Easily we can find. That function you take as second function. G of x. Okay now, like this you find. So otherwise we are following in this order. We are following for choosing the first function, second function. We are following in this order. I. What is the I? So I for inverse trigonometry. I for inverse functions. I for inverse functions or inverse trigonometry functions. So, for example, sin inverse of x, cos inverse of x, tan inverse of x. These are inverse trigonometry functions or inverse functions. L for logarithmic functions. Logarithmic functions, example, log x, log of sin x, log of log x. These are the logarithmic functions. A for algebraic functions. X square root t, y. These are algebraic functions. Next, T for trigonometry function. Well known. Sin x, cos x, tan x. E for exponential functions. Example, e power of x, a power of x, 2 power of x, 3 power of x, power of x. These are all exponential functions. Right? In this order, we are from left to right. We are choosing first function. In this order of left to right. Which one comes first? That one we are choosing as a first function or f of x. Right to left, we are choosing second function. Right to left, we are choosing second function. Example, you see, integration of x into sin x dx. X is which type of function? Algebraic function. Sin x is trigonometric function. So in this order, which is the first? In this order, which is the first? A is the first. So this is the f of x. Next, remaining is g of x. Right? Second one, you see, integration of x into log x dx. X is algebraic function. Log x is logarithmic function. In this order, which is the first? A is the first. So A is f of x, first function. Remaining is second function g of x. You see one more, integration of e power of x into sin x dx. In this, what is the first function? First to e power of x, which type of function? Exponential function. Sin x is trigonometric function. Which is the first one in this order? So t is the first one. So sin x is f of x. E power of x is second function g of x. You see now solution of first one. So how we are finding the solution? You see. So this is the first function. This is the second function. F of x is x. F of x is equals to what? X. And g of x is equals to what? Sin x. You substitute in that equation. This is equals to what? F of x first. F of x is x into integration of g of x. Integration of sin x dx minus integration of derivative of f of x. F of x is equals to what? X into integration of g of x. G of x is sin x dx whole dx. This is equal to x into integration of sin x is minus cos x minus derivative of sin x. Derivative of x is 1. Integration of sin x is minus cos x dx. This is equals to minus x cos x minus into minus plus integration of cos x is sin x. This is the solution. Again you see integration of x into sin x dx. X is algebraic function, sin x is trigonometric function. So f of x is x, g of x is sin x. You substitute in that equation. So it is in the form of integration of f of x into g of x dx equals to what? F of x sin x integration of g of x sin x dx minus integration of derivative of f of x. So derivative of x into integration of g of x sin x. X into integration sin x minus cos x minus integration of derivative of x is 1. Integration of sin x is minus cos x. So total x into minus cos x minus x cos x minus into minus plus integration of 1 into cos x is cos x. Integration of cos x is sin x. After the integral, we are adding integral constant c. This is the solution.